So today's lesson, let's talk about drawing on the ACT. There will be space on the ACT for you to be able to draw. You can draw all over the diagrams that they give you. You can draw anywhere on your test, particularly in the math section. And there's no reason not to. You have to be good at drawing in order to do well on the math portion. Now, you don't have to be an artist, but you do have to be able to visualize what you want and then be able to draw it. So since you are able to, I definitely suggest that you do. It can make some problems easier. Some quick thoughts before we try a few problems. Draw big. If you are asked to draw something, don't make it so tiny that when you try and draw lines or you try and meet the stipulations of the question, you can't do it because you ran out of room. Make it nice and big. You have plenty of room on the test to use it. Definitely follow all descriptions and requirements. There's going to be stipulations that might speak about slope or things being tangent. Definitely follow what it's saying and be sure you're drawing it correctly. Reread real quick. It doesn't take long, and you want to make sure your diagram is accurate. And then the last one is label and draw neatly. If I draw a grid and I decide to make my tick marks this far apart and say, well, this is 4, that's a problem. Look at how far apart each piece is. This is about that far, this is this much further. That's not a great drawing. You want to be at least slightly accurate and draw neatly. So let's look at a couple examples where I might want to draw. So this question asks about perimeter. It has a unique shape to it, and it's kind of hard to tell. And some of us might want to try and start solving for these two values. I know that this is 12. That's not bad. But I want the perimeter. So those two values I don't know. I also don't know this one over here. So you might try and start solving for that. But here's a big tip on problems like this, especially with perimeter. Notice x, if I were to move it over to the right, would be here. And I could take that 10 feet and move it up here. So now I've got 10 feet here. And I don't know here, but I will know in a second because if I move y out to the right, and this 10 down, because that is also 10, it has to be, look at what I've done. I know that y I moved over with the x, y, and z has to be a total of 20 feet. So if I'm doing perimeter, I have already solved it. I've got 20 plus 12 plus 10 plus 20 plus 10 plus 12. So by almost popping out that diagram, by moving the x out and the 10 up and the y out and the 10 down, I can find my perimeter. Perimeter is the total distance around. So 40 plus 22 plus 22 should give me 84. Not too bad. How about another one? So this one, in the figure above, what is the value of z? So when I'm looking at this, they tell me that x is 50. There's no reason not to write 50 where there's the x. It says that y is 20. So I'm going to label those things. So now I'm labeling. I'm using my labels. Next thing I need to realize is that this is an isosceles triangle. If those y's are 20, I know that this whole thing has to split the 180 degrees left over after 50. So 180 minus 50 is 130. So that means split in half, each of these are going to be 65 degrees in total. So this whole angle is 65 degrees. That's the only way this can be. So if that's the case, that means that these two are 45, which leaves my angle z, which is what I'm looking for, to be 90 degrees, because that smaller triangle, the red marks, have to also add up to 180. So using labels on your diagram is a great way to get this done. Let's look at the same drawing, but I'm going to remove a piece that you might need to recognize that I have to draw. Whenever you see shapes on the ACT that are familiar, definitely draw extra lines. It's okay to do so. Sometimes we actually have to. In this case, it makes the problem a lot easier if I'm able to draw that base and see that this is an isosceles triangle because those y angles are the same at the bottom. So if this were given to you without the base, you need to look at it and say, okay, I see an isosceles triangle if I draw a line here. That makes your problem infinitely easier. You can do it without that, but it's going to make it a lot harder. Also, the fact that it looks like 90 degrees for your Z does not mean that it's necessarily 90 degrees. It was a good guess, but it's not necessarily accurate. We cannot assume 90 degrees. All right, last little bit. And these are the two, we're going to do two of these on our quiz today, similar problems where you just have words. So let's look at some words. So no diagram given whatsoever. It says 3 parallel lines in a plane are intersected by a fourth line creating 12 angles. So what's the way I could do that? Well, if I draw the fourth line parallel, that doesn't make any angles. It's going to have to be a transversal. Great. Then it says one of these angles has a measure of 28. How many of the other 11 have a measure of 28? So if we know our vertical angles and our geometry, we know that there are 1, 2, 3, 4, 5 more angles that are 28 degrees. So I would be able to answer C. But this problem gave me absolutely no diagram. I had to come up with the drawing. So whenever you're given words, be sure that you are drawing as accurately as possible. You have plenty of space to do it. Draw nice and big and be sure you label.